Hi everyone, Mr. Spooner here to teach you about absolute value in zero product property inequalities. All right, before we go, you're going to have to make sure you're a really good equation solver. So let's see if we can solve this one right here. Absolute value of 2x minus 3 equals 7. It hasn't been that long. So you write your two equations. You have the positive case, 2x minus 3 equals 7. You have the negative case, because an absolute value could be positive or negative inside there, it would still make it positive 7. And if you solve this, I'm going to skip a couple steps, add 3, divide by 2. You would get that x could be 5, or, oh, look at this one has nice answers. Always exciting. Or x could be negative 2. So x could be 5 or negative 2. You plug those back in, the absolute value would equal 7. What happens when we make it an inequality? Well, you're going to sense a theme here as we do all these problems today in this video. I would like you, first step, to turn that inequality into an equation. That is going to be our first step. Now, I'm not going to resolve this. We know our answers are going to be 5 or negative 2 from over to the left. Now, here's the difference. When you have an inequality, you're not just going to get two answers. You're going to get a range of lots and lots of answers, dare I say even infinite. So the way we're going to express that, the easiest way I know how, is we're going to throw those answers, 5 and negative 2, on a number line. So I write a little 5 with a circle. I write a little negative 2. I make sure I put them in the right place. And then I go back to what I know about inequalities. This is a greater than sign, not a greater than or equal to sign. So I leave those circles open because they are not going to be included in the answer. And now I need to figure out where I'm going to squiggle. Do I want answers that are less than negative 2? Do I want answers that are between negative 2 and 5? Or do I want answers that are bigger than 5? And I'm actually going to plug in some test points just to see what works. So less than negative 2, I know a number that's less than negative 2 is negative 3. Between 2 and 5, negative 2 and 5 is 0. And bigger than 5, I know a number there is 6. Notice I'm plugging in something that's in between those answers I got. I'm not actually plugging in negative 2 and 5. So I'm going to start with 0 because that's the easiest. I'm actually going to plug that in to my original question. 2 times 0 minus 3, absolute value of that, is that greater than 7? I don't know. 2 times 0 is 0. 0 minus 3 is negative 3. The absolute value of negative 3, is that greater than 7? No, 3 is not bigger than 7, so 0 does not work. I'm going to write no. How about 6? Notice how I'm saving my negatives for the end because that's hard. All right, let's do 6. I'll just talk through it here. 2 times 6 is 12. I'm plugging into the original problem. 12 minus 3 is 9. Is 9 bigger than 7? It is, so I'm going to squiggle in that region. How about negative 3? 2 times negative 3 is negative 6. Negative 6 minus 3 is negative 9. Is the absolute value of negative 9 bigger than 7? Yeah, 9 is bigger than 7, so I'm going to squiggle right here. So this right here is my answer. This says that any number bigger than 5 would satisfy this inequality. Any number smaller than negative 2 would not. And everything in between negative 2 and, I'm sorry, anything smaller than negative 2 would, excuse me. Anything in between negative 2 and 5 would not. And if you don't believe me, try some other numbers. The one thing I want you to start noticing is, notice how the answer goes yes, no, yes. It kind of toggles between working and not working. You're going to see that pattern a lot, and that's a good little way to check as you get answers. So if you think you understand what's happening here, let's actually go to an easier one. Absolute value of x is less than or equal to 5. Well, let's just make that into an equation. Absolute value of x equals 5. So x could equal 5, or x could equal negative 5. I'm going to throw those numbers on a number line. We've got 5. We've got negative 5. And it's filled in now because it's less than or equal to. So these are part of our solution. And I don't know, do numbers in between work? How about 0? Is the absolute value of 0 less than 5? It sure is. How about something really big like 10? Is the absolute value of 10 less than or equal to 5? No, it is not. I don't squiggle. How about negative 10? No, that doesn't work either. So my answer is any number in between negative 5 and 5. Again, notice that off, on, off. It toggles between working and not working. And that's good enough, excuse me, for my answer. That's great right there. All right. How about you try this one on your own right now? Pause the video. All right, we're back. And did you get that as your answer? If so, nice job. Let's try another one. All right, let's do this one together. I'm going to go fast here because you've seen a couple. So first step, write it as an equation. We'll deal with that greater than sign later. Now, write my two equations. 19 minus 3x equals 2. 19 minus 3x equals negative 2. And let's see if we can solve these. So we get negative 3x subtract 19 is negative 17. So x is going to be 17 thirds. Wow. This one, subtract 19, you get negative 21. This one's a little nicer. X equals 7. It makes me nervous that they both were positive. Did I do that right? Negative, negative, minus 19. Yep, we're good. Throw those on a number line. So we've got 7. And we've got 17 thirds, which if you're wondering what that is, that's what, like 5 2/3? So a number in between would be 6. A number bigger would be 8. A number smaller would be 0. I always try to use 0 if I can. And let's see what happens here. Let's do 0 first because that's easy. 19 minus 0, 3 times 0. 19 is bigger than 2. It is, so we're going to squiggle there. How about 6? That would be absolute value of 19 minus 3 times 6. 19 minus 18 is 1. Is 1 bigger than 2? It is not, so we don't squiggle in the middle. And then how about 8? 19 minus 3 times 8. That's 19 minus 24, which is negative 5. The absolute value of negative 5 is 5. 5 is bigger than 2, so we squiggle over here. And that's my final answer. Bigger than 7 and less than 17 thirds. All right, try this one on your own. Pause the video, come on back, and this one has a lot. This one has a lot. Let's see what you get. Did you get less than negative 5 halves and greater than 19 over 2? If so, nice job. You can see down there. All right, let's keep it going. One more absolute value inequality. 5x minus 1 is less than negative 4. If you've been listening to me, you're going to make this into an equation. But then you might actually think to yourself, wait a second, an absolute value can never be equal to a negative. What if I go back up here? Could an absolute value ever be less than a negative number? Whatever we put in over here, we're going to get something positive or 0. It's never going to be smaller than negative 4. So you should actually stop right here, do a little thinking, and realize that this one has nothing that will work because no number you plug in will ever be smaller than a negative. So this one is NRS. So even though I'm giving you some strategies, you still want to stop and think, especially when you see a negative equal to an absolute value. All right, that was the absolute value portion. Let's do a little ZPP. You're going to see that the steps are very similar. X minus 2, x plus 3 is greater than 0, greater than or equal to 0. First step, same thing. Let's just pretend like this were an equation, not an inequality, because that's easier to deal with. So what would make this part 0? It would be 2. What would make this part 0? It would be negative 3. And we're going to throw those on a number line. And let's see, it's greater than or equal to, so I'm going to fill in my circle because this is going to be part of the solution. Same thing now. I'm going to pick some points that are not 2, not negative 3, but in between and on the outside. So let's try negative 4. Let's try 0. Let's try 5. And we're going to plug it in. Let's try 0 first. If we do 0 minus 2 times 0 plus 3, is that greater than or equal to 0? I don't know, negative 2 times 3 is negative 6. Nah, I don't think negative 6 is bigger than 0, so that's a big no from this guy. How about 5? 5 minus 2 is 3. 5 plus 3 is 8. 3 times 8 is positive, so this part's going to work. And again, if you're like me, you're thinking, okay, this part didn't work. this part did work. The middle part didn't. I think this is going to work, but let's make sure. If you plug in -4, it's going to be -4 minus 2 is -6. -4 plus 3 is -1. A negative times a negative is a positive, which will be greater than or equal to 0. So this is going to be your answer right there. Anything less than -3 or equal to, and anything greater than or equal to 2. All right, try this one, which is a little different on your own. Pause the video, come on back. Uh-oh, it's blocked by my little Screencastify thing. Let's move it over here for a second. So, did you get this as your answer? You had to do a little ZPP solving, get everything on one side, and then if you did your test points, you should have gotten bigger than 3 and less than 0. All right, we got one more to show you, then I'll give you a practice, and then I'll get you out of here. What if you have something like this? The steps are going to be the same. You are treating it like an equation. So you're getting your answers of 0, of -3, of +2. You're throwing those numbers on a number line. You're leaving your circles open because it's less than, not less than or equal to. If you're me, you're trying to talk while writing, which is tricky because I'm multitasking. And now I need to pick some test points. I'm going to say -4. I'm going to say -1, +1, and 3. I'm just picking numbers that are in between these boundary regions. And now I'm going to show you something that I do when it gets a little bit more complicated. I'm going to write down here 3, colon. And what would happen if I plugged in 3 to this original problem? Well, I know I would get 3 times 6 times 1. And I don't actually care that the answer is 18. All I care is that this gives me a positive number. And I know that a positive number will never be less than 0. So I know that 3 does not work. Let me show you that one more time. If I plug in 1, I actually don't care about the numbers. I just care if it's positive or negative. So if I plug in, I don't like how that looks. If I plug in 1, colon, I'm going to get a positive. 1 plus 3 is 4. That's a positive. 1 minus 2 is -1. That's a negative. And a positive number times a positive number times a negative number is a negative number. A negative number is always going to be less than 0. So I know that this region right here works. If you plug in -1, you'll get a negative times -1 plus 3 is 2. That's a positive. -1 minus 2 is -3. That's a negative. A negative times a negative times a negative times a positive times a negative is a positive, which will not be less than 0. So that's a big no for this part. And then let's try the last part, -4. That would be a negative times a negative times a negative. 3 wrongs make a wrong. That works. And again, you get that nice on, off, on, off, on, off pattern that we've seen throughout this video. And we see that that is our final answer. All right, I've got one more for you to practice. Pause the video, try it out. Did you get this answer? Ba-bam! And if you did, nice job. All right, that's it for me. Hopefully this made sense. If not, watch it again. It'll make more sense. See you later.